Welcome back to my channel. Today we are going to learn about Ohm's law and electricity. Yay! Do you know why yay? Because we got to use really cool equipment. And look at this. Light bulb is lighting up. Okay. Now before we start our experiments, we have to talk a bit about electricity. So what is electricity? Well, electricity is a non-stop flow of electrons through a circuit. Now let me show you an example of electricity. Look, this is electricity. Okay. So that's an example of electricity. Now, what do you need to create electricity? Well, you need a power source, which is this battery over here, then you need wires to connect and make a circuit. So this is what you need to make electricity. Now, have you ever heard the word voltage and current when you are talking about electricity? Well, I have, but do you know what it means? Well, voltage is how much pressure the power source can provide it to push the electrons through the circuit. Okay, so that's what voltage is. Now the next word, current, what does that mean? Well, it means the total number of electrons which is in the circuit flowing through the circuit at any given amount of time. Okay, so now we know what current and voltage is. Now we're going to talk about what Ohm's law is. Ohm's law is actually an equation, and the equation is current equals voltage by resistance. Now before we talk about what resistance is, I want to tell you something. Whenever voltage goes up, current goes up too. Like, let me show you this experiment to prove it. This over here is a 1.5 battery. Over here, I put two batteries which are 1.5, and together they will have the voltage of 3, and this one only has 1.5 voltage. Okay. Now I'm going to put the switch on at the same time, and you have to predict which one will light up brighter. Well, that was definitely this one which lit up brighter, right? Well, why is that? Didn't I just tell you that voltage, when it's higher, current goes higher? So because the voltage was higher over here, the current was higher, and that made a light bulb light up brighter over here and a bit less here. Okay, now let me tell you what resistance is. So inside the word resistance, that's the word resist. And do you know what resist means? Resist means to make something harder. Okay? Now, what do you think the word resistance will mean in electricity? Well, that will mean that the flow of electrons is going to be hard for the electrons to flow. Okay? Now, let me show you this. The switch is not on. Look at how dim it is now when I connected the resistance. Well, do you know why? Well, that's because when I connect the resistance, some of the electrons will get lost, or it will stop and get stuck over here. So that is what a resistance is. So now we know that whenever voltage goes up, current will go up with it. But whenever voltage goes down, current will decrease with voltage. Okay? And we also know what resistance is. We're almost done, but we have to talk about insulators and conductors. Okay? So every single thing in the world eventually has to let electrons pass through it, but not in the same speed. So over here I have this piece of plastic and this zinc electrode. Now look at what happens when I do this. The light bulb lights up immediately, right? Now I'm going to put this plastic over here And look, it's so hard to even see the light bulb lighting. Now why is this? That's because plastic is an insulator or a bad conductor of electricity. But this zinc electrode is made out of metal, and metal is a good conductor of electricity. So now this is why when I put the zinc electrode, it light up immediately, but when I put the plastic electrode, when I put a piece of plastic, it didn't really light. Oh wait, the reason that lit up is because I connected it. I'm sorry about that, friends, but if I don't connect these two, then look at it. Okay. Now I'm going to tell you why this is really important nowadays. Here's one reason. Well, see, this is a wire over here. Now on the outside you can see mostly plastic, right? But if I cut this open, then I would see that there's metal in the inside of it. And see, there's a bit of metal poking out here too. Okay, now why is this very important? Well, it has to be metal on the inside, otherwise the electrons won't flow, right? But why is it important that there's plastic on the outside? Well, one reason is because if there was no plastic, there's a chance of electrons jumping out of it. And you know that won't be good at all, right? And also, if we touch it, then we might get a shock because the electrons might jump off and get into your hand. So, this is one reason why it's really important about that there is bad conductors of electricity and good conductors of electricity. This is the end of our video. Bye.